There's an alternative way, well, there are actually several ways of solving this utility maximization problem. Let me show you another way that's kind of neat. So here we have this same utility function, same budget situation and constraint. What I want to do is normalize the exponents to sum to 1. So in general, so x raised to the power of a, y raised to the power of b, z raised to the power of c. And to normalize exponents to sum to 1, we're just going to do the following. A divided by the sum of a plus b plus c. On the variable y, it's going to be b divided by the sum of the exponents, and so on. So in our case, a equals 2, b equals 1, and the exponent on z, which is c, equals 1. So following these steps here, we're going to get x, which is 2. It's going to be 2 divided by 4. Okay, if we sum these up, that's 4. So 2 divided by 4 is 1/2. And then on the exponent on y, b is 1. Dividing it by the sum of the exponents, it's 1/4. And the same thing with the z variable. So why did we do that? When we have this formulation here, this Cobb-Douglas type formulation, 1/2 the consumer's income will be spent on good X. So the exponent here on good X tells us that 1/2 the consumer's income will be spent on good X. What does that mean? 0.5 times the income will equal the price of good X times the number of units of good X purchased. So if we solve this for X, okay, just dividing through by the price of good X, we're actually getting the demand for good X. This right here that I'm circling, that is the ordinary demand for good X. And since M is 10 and the price of good X is 1, the consumer would buy 5 units of good X. We saw that result in our first method. As for good Y, 1/4 or 1/4 of the consumer's income will be spent on good Y. So 1/4 times M, 0.25 times M, will equal the total spending on good Y. Dividing through by the price of good Y, we got the ordinary demand for good Y, and now just substituting in income and the price of good Y, consumer will buy 2.5 units of good Y. And let's do the same thing for good Z. Because the exponent on Z is 1/4, and the sum of all the exponents sum to 1, we know that the consumer will spend 1/4 of his or her income on good Z. So doing this same thing here, dividing through by the price of good Z, we get the ordinary demand for good Z, and plugging in income and the price, consumer will buy 2.5 units of good Z. Okay, that's it. I hope you found this video helpful.